Let's start to Laplace and inverse Laplace transformation on the Matlab. For example, we have a function ft is equal to 3 times e to power of minus 5t cosine t minus e to power of minus 5t sine t. Let's get the Laplace transform of this function on the Matlab. To do this, in here we have to define the function, but as you see here we have some variables, symbolic variables such as t. So we have to define first of all this kind of signals as symbol on the command window. In here, in this function, as you see, we have only one symbolic variable, which is t. So SYMC t, then we continue. F is equal to 3 times e expressed as exp in the Matlab, exp minus 5 times t cosine t times here, and minus exp minus 5 times t times sine t. Then we get the function as like that. If you want to get the Laplace transform of this function, we can use the Laplace command. Okay, f is equal to Laplace of f. Then we can get the Laplace transform of this function. As you see here, we get the Laplace transform of this function. It's so easy in the Matlab environment. Maybe we can simplify this expression by using a command. F is equal to simplify fraction of f. Sorry, we have to write uppercase to f. Then we can get the simplified expression for the f. We can also show this function as in this form, pretty, by using the pretty command, pretty f. Then we can see this function as in this form. Okay, that's all. It's so easy. Now let's do this question. 2 e to power of minus t cosine 10t minus t to power of 4 plus 6 e to power of minus t minus 10. What is the function? Ft is equal to 2 times x minus t times cosine 10 times t minus t to power of 4 plus 6 times exponential minus t minus 10. Then we can get the Laplace transform of it. Laplace f. We can get these results. We can simplify this expression. It is so complex now. Okay, this is the answer for this question. Now we can learn the inverse Laplace transform. For the inverse Laplace, we will use I Laplace and the expression. Okay, this is the command to find the inverse Laplace. Okay, let's do a question now. If we have fs is equal to s plus 4 over by s square plus 5s plus 6. Okay, let's do this question now. F is equal to parenthesis by s plus 4 divided by s square plus 5 times s plus 6. As you see here, s is unrecognized function, so we have to define first of all s symbol. Okay, SYMC S, and then we can write the same function. We can apply the inverse Laplace command as I Laplace F. As you see here, the inverse Laplace transform of this function is 2e to the power minus 2t minus 2t minus e to the power minus 3t. This is the inverse Laplace command. Let's do this question now. Fs is equal to s plus 5 over s square plus 6s plus 10. What is the function? F is equal to s plus 5 divided by s square plus 6 times s plus 10. Inverse Laplace transform of it, I Laplace F. Then we get e to the power minus 3t times cosine t plus 2 sine t. That's all. As you know, we learned a method to get easily inverse Laplace transform called as partial fraction expansion. Okay, by using the partial fraction expansion, we can easily get the inverse Laplace transform of any function. In the Matlab, we can use RPK for the partial fraction expansion, residual, numerator, and denominator. This is the command to get partial fraction expansion. What does mean R, P, and K? R means coefficients, P is poles, and K is gains. As you know, we can represent the function for any function. For example, a1 divided by s plus s1, a2 over s plus s2, a3 over s plus s3, and plus k. In this form, k is gains, s1, s2, and s3 is poles, a1, a2, and a3 are coefficients. Okay, so we can get easily this form. R is a1, a2, a3. P is equal to minus s1, minus s2, and minus s3, and k is k. That's all. Fs is equal to s squared plus 9s plus 19 divided by s plus 1 times s plus 2 times s plus 4. For this question, first of all, we have to expressed this function with the numerator and denominator to use this form. To use this comment, we have to get numerator and denominator. For this function, we have already know the numerator coefficient 1, 9 and 19. What about the denominator? Maybe we can get another form. Yes, numerator is equal to 1, 9 and 19. Denominator, for the denominator, we can write another command called as con. Con is convolution and polynomial multiplication, okay? Which is 1, 1. 1, 1 means the first term, as you see. If you want to write an expression in the matrix or vector form, we can express this function as 1, 1, as you see. And what about the others? Con again. We can express in one con command these two terms. Okay, how? 1 and 2 and 1 and 4. As you see here, denominator can be calculated easily by using the con command. Okay, now we can find the RPK is equal to residue numerator and denominator. Okay, what is the R? R is coefficient, as you know. The first coefficient, which belongs to the minus 4 poles, is minus 0.1667. The second coefficient, minus 2.5, which belongs to the minus 2 poles. And the last one, 3.666 and 7, which belongs to the minus 1 pole. So we can express this function as minus 0.1667 divided by s plus 4. Then we continue minus 2.5 divided by s plus 2. And the final one, plus 3.6667 divided by s plus 1. Then we can get easily the inverse Laplace transform of this expression. As you know, ft will be equal to minus 0.1667 e to power of minus 4t minus 2.5 e to power of minus 2t plus 3.6667 e to power of minus t. Okay, that's all. We can easily find the inverse Laplace transform by using the residue command as like that. I will give another expression. Fs is equal to 11s plus 28 s plus 2 square s plus 5. Let's get the residue and get the coefficient of this function. Numerator is equal to 11 and 28. Denominator is equal to, as you see here, we have multiple order function. We can easily express as, con, and then get the second one with the same pole 1 and 2, and again 1 and 2, and then all of them with the 1 and 5. Okay, then we can express RPK with the residue form, numerator and denominator. As you see here, minus 3, 3 and 2, minus 5, minus 2 and minus 2. That's all. The other topic is solution of differential equations by Laplace inverse Laplace transform. For example, if we have d square yt divided by dt square plus 3 dyt over dt plus 2yt equal to 1 plus t. Okay, if we have this kind of function and assume that this initial condition y0 is 0 and derivative of y0 is 1. Now we will find the Laplace transform of this expression. First of all, how can we get the Laplace transform of it? Let's do this together. This term s square ys minus sy0 minus derivative of y0. This is the first term, and then we continue 3 times with the second term, sys minus y0, and the last term 2yt 2 times ys, which are equal to the Laplace transform of 1 over s. What about the t? It will be 1 over s square. Okay. Then we can arrange this function as s square plus 3s plus 2ys is equal to s plus 1 divided by s square. Then we get ys will be equal to s square plus s plus 1 over by s square plus 3s plus 2. After finding this function, we can easily get the yt by using the Laplace command. Okay, let's do this now. F is equal to s square plus s plus 1 divided by s square times s square plus 3 times s plus 2. Okay, this is the f function, so we can get the time domain expression as by using the inverse Laplace command, of course, inverse Laplace of f. Then we get this expression. That's all. It is so easy with the Matlab. We can find the same expression by using the residue. How? Numerator, as you see here, will be 1, 1 and 1. Denominator will be 1, 3, 2, 0 and 0. Sorry, we have to use bracket parentheses here. This is the denominator. Then we get the RPK as the numerator and denominator, minus 0.75, 1, minus 0.25. It's about the minus 2, for example. This coefficient belongs to the minus 2 poles. So it means minus 0.75 times e to power of minus 2t. Where is it? Let's find it now. Yes, here, minus 0.75 times e to power of minus 2t. This is the first one. The second one, coefficient is 1, pole is minus 1, so it will be e to power of minus t. Where is it? Yes, e to power of minus t. The third one, minus 0.25 times e to power of 0. So it's mean, as you see here, minus 0.25. And the last one, this is the multiple order, as you know, so we get t expression also. So 0.5 times with t. That's all. Yes, I will give another expression to you now. Yes, what is the initial condition for this question? y0 is 0. Derivative of y0 is 0. The second derivative of y0 is minus 1. Let's get the inverse Laplace transform of this function. This question, first of all, we have to get the Laplace transform of it. It will be s to the power of 3 ys minus s square and y0 s times the first derivative of y0 and the second derivative of y0. This is the first term. And then we continue 4 times and the second term s square ys minus s times y0 minus the first derivative of y0, and we continue from the next term 6 times sys and minus y0, and the last term will be 4ys. It will be 0. Okay, then we can arrange this function as s to the power of 3 plus 4s squared plus 6s plus 4 ys. It will be 1, so the ys is equal to 1 over s to the power of 3 plus 4s squared plus 6s plus 4. That's all. So we can easily find the Laplace transform by using the inverse Laplace expression. 1 over s to the power of 3 plus 4 times s to the power of 2 plus 6 times s plus 4. Then you can get y as I Laplace y. Then we get this expression. If we have this kind of circuit R, L and C, series RLC circuit, the input of this ET and the output, assume that capacitor voltage, and the value of R is equal to 1 ohm. L is equal to 0.5 Henry and C is equal to 0.2 Farad. Yes, assume that ET is equal to minus 2 UT. And we have some initial conditions as EC0 is 5 volt and the first derivative of EC0 is 0. Find the ECT. This is the question. Find the ECT for this circuit. For this question, we can write an expression for this loop. As you see, ET will be equal to R times IT plus LdIT over dt plus ECT. And in this expression, we know this IT is C dECT over dt. So we can use this equation into the first equation. Then we get ET is equal to RC dECT over dt plus LC d square ECT over dt plus ECT. Then we write the exact value for this function. For the ET, we will use minus 2 UT. R is equal to 1 and C is equal to 0.2, so it will be 0.2 dECT over dt, and L is 0.5, C is 0.2, it will be 0.1 d square ECT over dt plus ECT. If you arrange this expression, you will get d square ECT over dt plus 2 dECT over dt plus 10 ECT will be equal to minus 20 UT. So if we get the Laplace transform of it, S square ECS minus S EC0 minus derivative of EC0. This is the first expression, second order derivative, and then we continue 2 times S ECS minus EC0. This is the second term, and the last one 10 ECS. It will be minus 20 over S, as you know. So we can arrange this expression S square plus 2S plus 10 ECS minus 5S minus 10. Yes, and it will be equal to minus 20 over S. So we can get the ECS as 5S square plus 10S minus 20 over by S square 2S plus 10. Okay, Then we can get easily ECT by using this expression. This is the Laplace transform of the ECS. Let me find it now. EC is equal to 5 times S squared plus 10 times S plus, minus 20 over by S times S squared plus 2 times S plus 10. Then we get ECT as I Laplace EC as like that. Okay, this is the 7 e to the power of minus t cosine times with cosine 3t plus 0.33 sine 3t minus 2. That's all. Also, you can use the residue command to find this expression. Maybe we can draw this function in the time domain. If we write for the t, it will be start from 0 and with the time range 0.001 and until the 10. Okay, if we use t as like that, maybe we can write EC will be equal to, by using this expression, we cannot use because t is a vector now. We have to use vectoral product expression here. Okay, to do this we have to write point before the multiplication operator, as you see here. That's all. Then we can plot the expression, we can draw this expression according to the t as like that. This is the ECT value. Okay, maybe we can use the guidelines as you see here. Let's examine it. The first value of ECT is 5. Where comes from this value? As we said from the question here, the first value of the EC0 will be 5. Okay, so it will start from 5. Then it will decrease as like that. Then the final value will be minus 2. What does minus 2 mean for us? What is the input for this question? Minus 2 already. So as you know from the circuit theory, the final value of the capacitor voltage will be input voltage for the series RLC circuit. Okay, you can easily see that it will start from the initial value, then it will continue until the input voltage value.